Greetings to all. Today we will be talking about ECG. We will be starting from the basics, and then we will eventually proceed towards the different aspects, how to understand the rate, rhythm, or if there is any kind of atrial enlargement or any kind of atrial ventricular hypertrophy, or you can say bundle branch blocks, or we will also be discussing about the MIs, and eventually we will proceed towards the arrhythmias. First of all, while talking about the basics, suppose this is our heart. I am drawing a schematic diagram. So this is our heart, and if I take a portion from here, suppose I take a portion, and this is the myocardium. So in myocardium, what it is there is that we call resting membrane potential. So when there is no any electric transmission, then inside the cell there are negative charge, isn't it? And outside we can see the positive. So when there is any stimulus, suppose there is any stimulus given to it, then eventually what it becomes is that the polarity changes. Gradually it becomes plus, and here it becomes minus. Initially it is minus, minus, minus. Again it propagates. So in gradual phases it becomes like this, and eventually when it progresses, then it becomes fully polarized. So this is the basic diagram representing that how the electric impulses propagate in the myocardium. So basics of electrophysiology we have talked. Now what it is important to know is that understanding ECG is like going back to basic sciences and plus 2. In plus 2 what we have understood is that suppose this is the myocardium, and it is in its resting membrane potential. So initially inside here it will be negative. So suppose I place a galvanometer here. So ECG is just like galvanometer. It just records the deflection, whether it might be positive or negative, and the rate in which how the deflection take place. So initially, suppose this is one electrode which is connected to this end, and this is another electrode which is connected to this end. So initially what it is that the myocardium is in resting membrane potential. So the change in potential is 0, because no any electricity is flowing, no any electric impulse is flowing. So suppose if this is the positive electrode, then this is the exploring electrode, it will not find any difference in the potential. So there will be no deflection. That's the first thing to understand. Now another thing to understand, now in second case we will discuss the second case. Suppose there is some electric impulse given into it, and because of electric impulse the polarity changes inside the cell. So what you can see is that here the positive vector, because gradually inside the cell the positive polarity is gradually moving towards the this end. So suppose if there is positive electrode and there is negative electrode, and in case of galvanometer when you measure, then the deflection will be moving towards the positive side. Suppose this is 0 and this is positive side and there is negative side, then initially it was here 0, no deflection, because there is no change in the polarity, or electric impulse is not going anywhere. But in this case, when the stimulus is given inside the cell, the polarity is changing gradually, and the positive vector they are moving from this side to this side. So one mnemonics or the one logic what you can obtain is that when positive vector is moving towards the positive side, the deflection is also positive. So there will be positive deflection. So this thing you keep in mind. Okay. Now when the impulse is gradually progressing and progressing, there will be the phase when the cell becomes fully polarized, isn't it? So the action potential has propagated throughout the cell, and in this case when you measure it, there will be no any potential change, because it has fully polarized. So again the deflection will be null, or there won't be any deflection. So this is the basic understanding. What you need to understand is that When positive deflection moves towards the positive vector, moves towards the positive electrode, there will be positive deflection. And the reverse holds the true. For example, so now it is fully polarized here. Now after a while it becomes repolarized. So what will happen is that this is our same myocardium, isn't it? Now initially the propagation took place in this direction. Now repolarization will take place in this direction. So what will happen? Here it will be negative charge, and here will be positive, 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 positive. Outside it will be negative, here it will be positive, positive. So we have our exploring electrode here, and this is our negative electrode. So when we connect this to our galvanometer, what it will be finding is that here the negative vector, the resultant negative vector is going towards negative electrode. So negative going negative will also give you a positive deflection. So this will be positive deflection if this is 0. So this much you have to understand in this phase. So the first logic is that if a positive vector of inside the cell is going towards the positive electrode, then the deflection will be positive. And if negative vector is going towards the negative electrode, then the deflection will also be positive. If negative to negative, positive, positive to positive, positive deflection. But suppose let's say let me erase this diagram. Suppose we have our myocardium here. Suppose let's see, this is our myocardium, and let's say here we have the negative deflection, and here if it is positive deflection. So let's take one quick example. What will be your finding? Suppose here it is your negative electrode, and there is your stimulus, and here is your positive electrode. So what will be your finding? Here the positive vector is propagating towards the negative electrode, so the deflection will be negative. So that thing need to be kept in mind. Now in next video we will correlate that thing with the ECG finding.